Linear interpolation and extrapolation is what we are going to see in this lesson. Please don't forget to subscribe to the channel. Now here, this deals with the physical data of two variables whose quantities, whose equation joining them not given. Within extrapolation, linear interpolation, let us handle that and see. This is used if value wanted is between any two variables. Again, if you want this value say xn, and it's between 3 and 4. If these 3 are given and they are corresponding value of the other variable, it means that we can get this xn. So here I use interpolation because you see it's in between 3 and 4. Then in extrapolation, this is used when the wanted value of xn is outside the range of given values. For example, if they give us 3 and 4 and xn is outside, there we use what we call the linear extrapolation. As there you see. Now, assumptions made here or assumptions used with the points, we assume that those points we are going to get these points on a straight line, the line on a straight line. Then we assume also that these points are close to each other. They are very close. Especially when we are dealing with extrapolation, they should be very, very close. Then to get the required variables, we can use the gradient approach or the first principles. Why do we use the gradient approach? Because we say we assume that this line, these points all lie on a straight line. So you can easily use the gradient or the first principles. You know how we use the first principles when we are getting gradients. Then consider line a linear function f of x below. If we consider this as a linear function, the x naught here is corresponding with f x naught, xn f xn, x2 f of x2. Now remember our gradient is saying change in y over change in x. You can say this is the change in y, this minus this over this minus this, equaling to this minus this over this minus this, as you can see there. That's how we get the gradient. Now, if I divide this side and I take this up, you see that this one is now this is true there. Now, how do you use this? The examples are very easy. Now, in most cases, make sure that the unknown you want is in the numerator so that you can easily simplify. So, use the table below to find the value of y. So, what is going to happen? You see, this is the missing value. So what you use here, you use a set which is having unknown and other two sets which are all the values are defined. So I'm going to use this and this. Then the next I use this and this. So we get a gradient of this and this, also the gradient of this and this. They are going to be equal because we assume that all these points lie on one line. So like we see, this point, and this point. So the gradient from here up to here is the same as from here up to here. That's why when I get a gradient between this and this, it's the same gradient between this and this, the same gradient between this and this. But now we use this with a known, with the one which is having two knowns, and then we also use this and this so that we can easily simplify our work. So what am I going to do? I'm going to set y. Now I take this set and this, then also this and this. So I say y minus. So you can easily set, if you take this as x, this is your y, you can say you are going to use now this minus this, y minus 1 over the corresponding, you be careful. So you say this minus this over this minus this, 4 minus 2. It will be the same gradient as saying this minus this, 5 minus x, 5 minus 1, 5 minus 1 over 6 minus 2, 6 minus 2. There you just simplify and you get your answer. This will be y minus 1 over 2 equaling 4 over 4. So this will be y minus 1 over 2 equaling 1. Cross multiply equaling 2, and our y will be 2 plus 1. And so our y will be 3. As simple as that. So this y, shows that this value is to read as simple as that. So what we've used in simple terms, we have used this point and this one. So we have used 1, 2, and y, 4. This is the first set. This one is what gave us this gradient. Then we also used 5, 6, and 1, 2. So you can go to the gradient between these two sets of points, and that's what is there. So that's it, members. We are going to see more examples about this. Now this one, we use the linear interpolation. Why? Because it's that our value was in between the given sets of data. Don't worry, I'm going to see more next lesson. See you there.